So the numbering might be out of order by now. I removed one of them. I just don't know if I changed the numbers or not. But anyways, sketch a graph of this piecewise function. This was something that was on the last test and y'all didn't do so hot on. Try again, right? There's a couple of you that still don't know your mom functions. The first thing up here is y equals 5. Notice it talks about x being less than or equal to -2. So we're going to go to where x is -2. We're going to go to where y is 5. And we're going to draw a horizontal line. And it's going to run left forever. All right. Next thing is y equals -2x plus 1. You know, you're supposed to realize that that looks something like that. That's what it looks like. You can make a table if you want. I like the tables, but that's me. I mean, it's what I do in my head. But I can let x be -2, and I can let x be 1. If I plug in a -2, -2 times -2 is 4, plus 1 is 5. So -2, 5 exists, which is already there. Even though it's an open hole, it's been closed by this one. And if I plug in a 1, I'm going to be -2 plus 1, which is -1. So 1, -1. That is closed if you look at your symbolism. And then I'm at y equals 1, so long as x is bigger than 1. And when it comes to the dot, she's open. Piecewise functions are not that hard. I did forget to connect these two dots. I should probably do that. There you go. Piecewise function. An easy one. Write an equation for a line perpendicular to y equals 3x minus 1 that passes through the point 6, -7. All right, if you're perpendicular, your slope is going to be the opposite reciprocal. Okay, so this guy has a slope of 3, so the opposite reciprocal slope has to be -1/3. Opposite on sign, flip the number. Passes through a point, we're going to use point slope form. Y minus y1 is m times x minus x1. Let's see, we have y take away a -7 equal to -1/3 of x minus 6. So y plus 7 is -1/3 of x. Negative times negative is positive, plus 2. And we're just going to subtract 7. 2 minus 7 is -5. Hopefully this will be a good test for y'all. You know, the hard one was probably that one. I took off the really hard one. I did. All right, we have the linear function. A couple of you guys were struggling with that initially, but then I think you got the hang of it. Think about your ordered pairs. This is x, this is y. So you have this ordered pair, -3, -1, and 5, 0. What's cool about this guy is absolutely nothing. So anyways, if you do your formula for slope, you'd have 0 take away a -1. Almost did it backwards. 5 take away a -3. You get 1/8. And I'm going to use this point right here, because again, I'm going to do point slope form. Y minus y1 equals m times x minus x1. Y minus nothing equals 1/8 of x minus 5. Do that distributive property. 1/8 of x minus 5/8, and y minus nothing is y. Ta-da! 15 determine if even, odd, or neither. Y'all didn't do so hot on this last test. Remember I told you I'd make this test cumulative so I could adjust your grade? So even, on an even situation, f of x is equal to f of -x. In an odd situation, f of -x equals -f of x. And if it's not either one of those, it's neither. All right. And if you're even and odd, then you have origin symmetry, which is kind of interesting. That happens sometimes. So anyways, I'm just going to go through and do the test. I need to find f of -x, because both of them require it. See that? That one requires it, that one requires it. And it's 1/3 times the -x minus 2 times a negative x that is squared. And if I square a negative, I get a positive, so that becomes just x squared. We don't do the distributive property. And this is 1 over negative 3x. Now, it doesn't look like the original. We've had a sign change. So it's not even. So now I'm going to do the odd test where I need to find this. Negative f of x. What is she? Well, you wrap the whole function in a set of parentheses. And then you distribute that negative to the signs. This becomes negative 1 over 3x plus 2x squared. And, you know, is that equal to f of negative x, which was right here? And the answer is no. So you're not odd. Therefore, neither. That's something I got to put on all your tests. That's on the challenge exam in the spring. Find the domain for which this function is increasing. Then find the inverse. Okay. The mom is x squared. And if we look at our shifts, we have a right 2 and an up 4. And we have this initial slope. Big thing is it's negative. This is just a quick rough graph. Right 2, up 4. Looks like that. But the reason I'm doing that is I want where this thing is increasing. And this is where it's increasing. I am increasing so long as x is less than or equal to 2. All values of x such that x is less than or equal to 2. And that's the main thing I'm looking for, is that you write down somewhere the x value. And now we're going to write the inverse. If you have forgotten how to write an inverse, it's pretty simple. Step 1 is literally get the f out. We swap x and y. Step 2 is to resolve for y. Step 3 is the profit, which is where we use that correct notation. And we go to town on it. All right, so if I get the f out, I'd have x equals negative 3, y minus 2, quantity squared minus 4. Do all the easy stuff first, you know. Add 4. X plus 4 is negative 3 on y minus 2 quantity squared. Divide out that negative 3. And you can clean this up if you want. I really don't care. I'm just going to leave it as x plus 4 over negative 3. And that's y minus 2 quantity squared. The opposite of squaring is to square root. So we take the square root of both sides. And then we add 2. So the root of x plus 4 over a negative 3, and that's all inside the radical, plus 2 is the inverse of f of x. And that thing only accepts values of 2 or less. See, this is why this is important. If I tried to feed this something bigger than 2, like perhaps a 5, or not even a 5. Sorry, I went like completely blank. If I fed it a 3, I'd be taking the square root of a negative, which is imaginary. If I fed it a 4, it'd be imaginary. But if I feed it a 2, I still have an issue. Well, I guess it just won't draw it for a while now, will it? Truth is, this thing can't take anything but things that are less than 4. But it just won't be drawn, so it's not a big deal. All right, what do we got here? Yeah, these didn't go so hot. Find such and such and state the domain. What was the domain that got y'all? So let's do the insertion. That goes there. It's the square root of 3 times x plus 3. and then add 4. That's going to be the square root of 3x plus 9 plus 4, which is the root of 3x plus 13. Now, as far as domain goes, on this one, it's not too bad. I know that for the square of anything, the stuff inside is greater than or equal to 0. So 3x plus 13 is greater than or equal to 0. 3x is greater than or equal to negative 13. X is greater than or equal to negative 13 thirds. And I don't really care how you do this. You can do this as interval. You could say negative 13 thirds with a bracket to infinity, because that's perfectly valid. Or you could just do set builder. I did not specify which one I wanted you to do, and I'm not going to specify which one I want you to do. All right, the next one's a little bit harder. We have 2x plus, we're doing composition again. Apparently I crashed it. That happens. It's not even there, is it? Hope I saved it. Oh, thank the Lord I did. Sometimes I don't save stuff. Okay, so I think I was on 18. I'm going to take this stuff right here and I'm going to put it right there. It's 2 times 3 over 4x minus 8. And then add 4. Now, the big deal here is we do not want the denominator for 0. For 1 over anything, anything cannot be 0. So I do not want 4x minus 8 to be 0. Because if I do, I got a problem. So 4x is not 8. X is not 2. And, you know, as far as the domain, you could do something like negative infinity to 2, you move it to infinity, or you can do set builder all values of x such that x is not 2. Now, you need to clean this up a little bit. I mean, you're smart enough to know that 2 times 3 is 6. Be careful about cleaning up things past that. This one should be cleaned up. Those are all evens. That's 3 over 2x minus 4. But, you know, by and large, 90% of the time, this is as far as you take it. That one's done. It wasn't too bad. The next one is one that I think only one person got right last time. It's average rate of change, which is one of the few things in pre-calculus that is actually calculus. Here you're going to do what's called the difference quotient. You're finding f of x plus h. Anywho, we're going to do the average rate of change formula, which I noticed a lot of y'all are leaving blank on the form quizzes. Now the bottom on this one's easy. It's x plus h minus x, which is just h. Now we find f of b by plugging in an x plus h. So it's 2 over x plus h plus 3. It's kind of funny looking, isn't it? And then f of a is literally the original function because you're letting x be x. It's 2 over x plus 3. So the top part of this fraction becomes 2 over x plus h plus 3, take away 2 over x plus 3. And that's the part you're going to have to work with. And it's not necessarily going to be pretty. In some degrees, this is kind of like cross multiplication, but it's not quite the same. I'm really surprised this one is so ugly, but it is. Anyways, Nothing I can do about the ugliness. I talked about it being kind of like cross multiplication. We're going to give this guy x plus 3. Take away, so take away 2. We're going to give it x plus h plus 3. Over a unified common denominator that is x plus 3 times x plus h plus 3. And it's all sitting pretty over an h. We're going to clean some stuff up. This would become 2x plus 6. This becomes minus 2x minus 2h. Minus 6. And things cancel. The 6's cancel, the 2x's cancel. And we're just left with negative 2h up top. It's over this fugly looking thing, which I'm not going to do anything with. And we're divided by h. Now, when you divide by a whole number, it's the same as multiplying by her reciprocal. And that makes these h's cancel. So we're left with negative 2 over that fugly denominator, x plus 3 times x plus h plus 3. And we don't really do anything with that denominator unless we're specifically asked to. I'm not asking you to do it. And that's that. Now, the other thing I want to do on this was the bonus questions, because why not? Got some bonus questions. Lost my sniping tool. There she is. You probably won't watch this part because you guys are a bunch of slackers. Like, it's bad. But whatever. That bonus 11 is a really good bonus for a linear algebra class. Lots of people say, I want to be an engineer, I want to be a scientist. The fuck you mean there's math? Yeah, there's math. Lots and lots of it. But the funny thing is once you decide that's what you want to be, you realize that math just becomes a tool. It doesn't become a hindrance, it becomes a tool, and it becomes more important to you. Or you're weird like me and you're just born liking math, and you never really figured out what to do with it. But that's okay. Sorry, I know I'm wasting your time. Don't feel bad, I'm wasting my time too. I don't usually do a worked out video for seniors in pre-calc. Anyways, give a recursive definition of the sequence whose nth term is n factorial over 4 to the n. So you may not remember what n factorial is, but like 3 factorial is 3 times 2 times 1, which is 6. So you know what I'm going to do? I'm going to figure out some terms here. The first term would be 1 factorial over 4 to the first, which is just going to be 1 over 4. Okay. The second term is going to be 2 factorial over 4 to the second. Well, that's going to be 2 times 1, which is 2 over 16, which is an eighth. And the third term is going to be 3 factorial over 4 cubed. So that's 6 over 64, which is 3/32. So I need a sequence that generates those 3 things. That's what I need. And I know the first term is a quarter, so these 2 are gone. They don't work. They're gone. So I'm going to see if the rest of them work. All right, so let's look at B. B has the first term right. It says the next term, this would be the next term, n plus 1. So it'd be talking about a sub 2, right? A sub 1 plus 1 is 2. It's going to be 1 plus 1 over 4 times the previous term, which is a quarter. So a sub 2 is going to be a half times a quarter, which is an eighth. That's cool, it worked. Let's see if it works again. Does it work for the third term, which I want to be 3/32? That's the real question, is does it work again? So if I do a sub 2 plus 1, n is 2, it's 2 plus 1 over 4 times the previous guy, which is an eighth. 2 plus 1 is 3, 3 times 1 is 3, 30 seconds. It's most likely that guy. That's the most likely choice. That's recursive rules. If you go into computer science, you'll begin to enjoy recursive thoughts. Find an expression for the determinant of the matrix A. This is the Greek letter lambda. You could probably game this in a calculator. I'm going to teach you how to do this. Not that it really matters. What we're going to do is we're going to copy down the first two columns. My Greek lambdas are going to look pretty bad. And I don't know if you remember doing like 2x2 matrices. It's AD minus CB. Right, we did several of those last year on the basics quizzes. We're going to do something similar. We're going to do these diagonals. Okay? Lambda times lambda plus 1 times lambda, which is kind of funny. That is a bad looking lambda. I'm just going to make it an L. And then we would have plus a 0, plus a 0. Notice how we're supposed to take away the upward diagonal. So take away all of this, 0 times lambda times 0, which is 0, plus 1 times 2 times lambda, which is 2 lambdas, and then lambda times 0 times 2 plus 0. So I've got something kind of funny looking here. I've got lambda times lambda plus 1 times lambda, which is choice A, but I'm supposed to take away this. I have lambda times lambda plus 1 times lambda, take away 2 more lambdas. It's probably going to be something along the lines of choice D or E. Probably E, because I see that minus 2 lambdas. So L times L is lambda squared. Distributive property, lambda cubed plus lambda squared, and then finally take away that 2L. Choice E. That is how you find the determinant of a 3x3 matrix. Now, if you take a linear algebra, they'll teach you a much different algorithm for it, but that's a special situation for 3x3s. Write an equation for the line that goes to the center of the circle, x squared plus y squared minus 2x plus 4y equals 4, and is perpendicular to the line 3x plus y equals 7. So let's do some grouping here. Half of negative 2 is negative 1. Negative 1 squared is 1. Add 1 to both sides. Half of 4 is 2. 2 squared is 4. Add 4 to both sides for balance purposes. Beautiful, huh? This factors is x minus 1 quantity squared. This factors is y plus 2 quantity squared. And this is 5. So this circle is centered at 1, negative 2. It has a radius of 5, which is just a little over 2. It looks a little something like this. And the line that goes through the center but perpendicular to something else. So this is y equals negative 3x plus 7. Okay. The perpendicular slope would be 1/3. Now we're going through the center with an increasing slope. This is the line you're writing an equation for. Now what's cool is you know the center's at 1, negative 2, and you have a slope. So we're going to use point slope form. y minus -2 equals 1/3 of x minus 1. So y plus 2 is 1/3 x minus 1/3. And if we take away 2, we'd have -7/3, if my brain is working right, which I don't even think I have to do. I think the answer is right there, isn't it? Yes, it is. Should pay attention to answer choices. This test was built for speed. The second and sixth terms of a geometric progression are 3/10 and 240/3 over 160 respectively. What is the first term of this sequence? Geometric means multiply or divide. And this doesn't seem too long. Every second, third, fourth, fifth, sixth. And let's just see if we can figure out what's going on here. If I doubled, I'd be 20, 40, 80. So I'm multiplying by something over 2. The top is probably about a power of 3. Like this is 3 to the first. 3 squared is 9. 3 cubed is 27. 3 to the fourth is 81. Yeah, that's 3 to the fifth. So the top is multiplied by 3. Now, if I divide by 3, I get a 1. If I divide by 2, I get a 5. 1/5. And I did that because I'm probably slightly autistic and I love numbers. I have no idea. I don't know where things come from. They just happen. Find the angle between the two vectors. Vector v is 3i minus 2j. This is x, this is y. So this vector v goes right 3 and down 2. Looks like a little bit like that. There's some formulas for this too. And then vector w is -i plus 4j, which means it goes back 1 and rises 4. Back 1, rises 4. Looks like that. What we want to know what this angle is right here. What is that guy? Well, it's obviously not B ray. I'd say it's probably C, and it's also obviously not D. It's probably C or D. I'm trying to think of the easiest way to do this one. There are formulas for this, but I'm not going to talk about the formulas today. I know that this is 90 degrees, right? Let's take a little look at this guy. This guy went right 4 and then down 2. That's what it did. Put a little angle there in the middle. We have opposite and adjacent. So the tangent of this angle is going to be, and it's technically negative, it doesn't matter, is 2/4. So the angle is the arctangent of a half. Make sure your TI-84 is in degree mode. Degree. Arctangent of a half. Tells me there's 26.57 degrees there, 26.6. All right, let's take a look at this guy. This guy went left 1 and it rose 4. So we'll just put another angle here. We'll call this one alpha. The tangent of alpha is 1/4. So alpha is the arctangent of a quarter. Take the arctangent of a quarter, and I get 14 degrees, roughly. So I've got, I think, 26 on the previous one. 26 and 14 is 40. Add the 90 that I had. The best choice is C. There's something, I'm not sure why we didn't line up perfectly there, but whatever. The best choice is C. I didn't make this test question, so who knows? The points of intersection on the graphs of x, y equals 20 and x squared plus y squared equals 41 are joined to form a rectangle. Find the area of a rectangle. This isn't going to be any fun, now is it? Not a lick of fun. I don't feel like doing this by hand. I'm going to divide the x out. Y is 20 over x. The other equation, I'm going to move the x squared to the right, and I'm going to counteract squaring by square rooting. Remember, square rooting is plus or minus. Now I have y1 and y2 and 3 respectively. $20 over x is going to be a funny looking thing. You should know kind of what it looks like. It's based off a mom function. All right, let's see here. We need the square root of 41 minus x to the second. And we need the negative square root. 41 minus x to the second. I'll do a zoom 6 to see what she looks like. But it says that we connect these points of intersection to draw a rectangle. That's what it says we do. So where are these points of intersection? And I'm assuming the rectangle is going to be something like that. So anyways, let me get a snipe of this. Snip, snipe. I don't know, I'm tired. Yeah, so it's gonna have to be a rectangle. It's not a very good looking rectangle though. But that was, oh, that's part of the problem. I did a standard zoom, didn't I? I should have done a zoom square. I'm trying to draw a rectangle. That'll make more sense for you. So what we're going to do is we're going to connect these dots together to form a rectangle. That's going to be a rectangle. So let's find some intersections and see what they are. Second trace 5. Let's see, it says I'm on the blue curve now. And pay attention to the x values. You get close, you press enter 3 times. That's nice. It was at 4, 5. I'm glad that worked out well. Somebody spent some time making this problem for you to get a nice number like that. I mean, they spent some time. They had an idea what they wanted, and then they manipulated it for a while until they got nice, clean answers. 5, 4. All right. I'm guessing these are going to be the same except negative. That would make sense. -4, -5, -5, 4. So how tall is this rectangle? This rectangle is 1 unit tall because that's the difference in y. No, it's not. No. It's going to be √2 tall anyways, we're going to do distance formula. Distance is the square root of x minus x, 5 minus 4 squared plus 4 minus 5. And that's going to be 1 squared plus 1 squared, which is going to be root 2. It's a root of 2 tall. Now we got to figure out how long she is. Square root x minus x, 5 minus a negative 4, quantity squared, plus 4 minus a negative 5, quantity squared. Those are both 9. That's 9 squared plus 9 squared, which is going to be root 162, 81, 81. So our area is the root of 2 times the root of 162, which is the root of 324. Which I feel like is 18. I'm not firing on all 8 cylinders today, as you can tell. Yes, it's 18. And that was every bonus question. Now, you only get full credit if you could show all the work. Probably won't even pay attention to that. That's the only way you get full bonus credit. Just memorizing the answer is not enough. It's something, but it's just not enough. There we go, kids. I am shot and tired.